All right. 1.3 is what we're getting ready to do now. We're still talking about functions. This whole entire class is about functions and again how they relate to real life. The first one, that's the specific type we're talking about, are going to be linear functions. Okay, linear functions. Then we're going to talk about the slope, because if it says the word linear, what shape do you think the picture or the graph is going to look like if it says linear? Some type of line. So therefore, we're going to look at the slope of the line and the intercepts associated with that line. So slope of the line, typically think of a slope like a ski slope. Can you be going downhill or uphill on the slope? No. Well, think about it. I'm asking a question. If you've ever been skiing, I've only been once, but it's been a long time. Are you either going down the slope or up the slope? Now, with up the slope, you got a ski lift going up, right? But coming down the slope, you're on the skis coming down the slope. So the question is, we're going to talk about the slope of the line and how to give you a numerical value for the slope of the line. So let's go to this next slide. For some reason, when I do next slide, the initial time, it doesn't always pop up, but now there it is. All right. What makes a function linear? We're going to talk about the graph of the function is a line, and you got vertical lines, which are not functions. And remember, to determine if a linear function is a function, you want to be able to do the vertical line test. So if you're given a linear equation and you want to know if it's actually a function, do the vertical line test. Type it in Desmos and see if it passes the vertical line test. The graph of every linear equation should look like a line. The slope is usually called the rate of change, or you'll see the number, and I'll show you in the next example what you should look like when it says rate of change. Things change according to a certain numerical amount, so we'll talk about that in more detail in a second. And then, whenever you see this equation that's on the board, here's the equation. Y equals mx plus b. You will need it for the first test. You will definitely need it for the rest of the class. That's called slope-intercept form of a linear function. Okay? Y equals mx plus b is called the slope-intercept form of a linear equation. Okay? Now, the letters or the variables in that equation stand for something specific. Now, remember, usually X stands for what? In general, what does usually X stand for? Input or output? Input. The Y usually stands for input or output? Output. So we know what the X and Y generally refer to, so you know those are input and output numbers. The question is, what is the M and what's the B? M is always the slope, and it's going to be a numerical value. It's going to be a slope, and it's going to be a numerical value. So it'll be some number. Also, you have your B, your variable B, which is your Y-intercept. It will also be a numerical value, but it always is on the Y-axis. It's a numerical value on the Y-axis. Okay? Alrighty, so here's an example of a linear equation. Y equals 3x plus 5. Okay? Can you tell me what the M value represents in this equation? 3. So remember, M is always 3. It's your slope. I don't know why they call it M, but that's what standardly is used in most mathematical texts. When you see Y equals mx plus b, M is always talking about the slope, and it will always be some number. Again, what's your Y-intercept? It's 5. It's always your B value. So again, here is M. I'm pointing to the B and the M, and they're also called slope and Y-intercept. You'll see me write Y-intercept in abbreviated version. I'll just put Y-INT for Y-intercept. Alrighty? You're good? Now, if you graph this line in Desmos, what do you think this line is going to look like? So if we actually take it and put it in a graph, and actually, let's go to Desmos and actually take a look at that particular line. So I'm just going to pull up Desmos so we can see what that line looks like. Delete what's here. We don't need it. Y equals 3x plus 5. We just typed it in. And let's erase what's on this board. So let's see, where's the eraser? No eraser. All right. So here we go. Let's actually, so you can see what actually is on the screen. There we go. There is the y equals 3x plus 5 line. It's an equation of a line. Now, how did we know that that line was going to be going? I call this uphill. I call this going uphill. Whoops, I wrote on the wall. Okay, the wall doesn't go over that far. That is uphill. Okay. All right. Whenever you see from left to right, I call that uphill. So again, I'm drawing a line from left to right going up, it's uphill. Whenever you see a line going down from left to right, this is downhill. I call it downhill. So you got to be looking left to right, from this way to this way. This is downhill, this is uphill. This is what I call it. So if it's uphill, and this is the slope, so we're talking about slope now. The slope is uphill. Is that going to be a positive or a negative number, do you think? Okay, since we're going uphill, that slope is going to be positive. Well, guess what the slope is going to be if we're going downhill? Aha, so here you're going to have a negative slope. Whoops, not positive. That's a negative slope for that one. So you can see what my expectation is. So I knew that line was going to be going uphill because what was positive?
3.
The 3 was a positive 3, so I knew that line was going to be going uphill. Now, the other question I have, this number tells me what again? The 5 tells me what?
The Y-intercept.
It's the Y-intercept, which means it what now? It intercepts or touches the Y-axis at that point. So if I scoot this screen up just a little bit so you can see it, if I scoot this up a bit, can you see that that's a 5 right there? And actually, let me go in and change my wrench for a second. Let's go in and change this to, oh, let's make it 15. And let's make this a negative 15. I'm just adjusting the screen so I can see what I want to see better. All righty. So can you say, or can you tell that that would be somewhere around 5? Can you see that this would be about 5? Where it touches the y-axis would be 5? Okay, so again, the y-intercept always touches the y-axis at whatever that number is that's at the end of the equation. If that number's a fraction, it's going to touch at a fraction. If that number's a negative number, it's going to touch down here on the y-axis, but it's going to touch somewhere on the y-axis. Questions? Alrighty, back to the PowerPoint. Alrighty, so here, we've defined what slope is and what the slope-intercept equation is that you're going to be using in this class. Next slide. Alrighty, let's see. What I call uphill and downhill, they call the steepness of the line. How steep is it? And the other way that we can look at this is rise over run. Have you heard that phrase before? Yes. Okay, how much you rose and how much you run. So we're going to talk about that part in a little bit more detail. And we just discussed what the variable m represents. And it represents what again? Slope. M always represents the slope. So here we go. Can you tell that that's a positive slope? For the pink line that you see on the screen, can you tell the slope is going to be positive? Okay. So with that, I want to know what the slope of the line. Let me see if I can pick one an easier. Not this one. I'll show you the next one. I was trying to see if I could show you the exact slope for that one. It has to hit on a certain point on the lines. So that one's positive. What about this one? Can you tell if that's a negative slope? From left to right is going downhill. It doesn't matter that it has arrows on both ends. That's just a line. But I wanted you to look from left to right. That's going downhill, so the slope is negative. All right. What about a horizontal line? Does it go downhill or uphill? No, it doesn't. So the slope is 0. So you can't say it don't have a slope. It does have a slope. The slope is 0. You understand what I'm saying? It's kind of like your bank account. You can't say I don't have no money. You have zero money. That's considered money, but it's just zero money, right? So same thing here. The slope for every horizontal line is zero slope. Now, vertical line, it doesn't go uphill or downhill or lay straight across. It has no slope whatsoever. You can't say it's got zero because zero represents a number. It is undefined. There's no such thing as the slope of a vertical line. So if they ask you that question and you say, well, it's got zero slope. Nope, that's not correct. It has no slope as if it's a vertical line. Questions? Alrighty, here. How do we calculate slope? It's like, well, how do we figure out how to calculate it? So looking at the slide that you see here, we want to find out what the slope of this line is. Alrighty. Question. Can you tell me, and again, the line that we're looking at is this line. So I want to make sure you're focusing on this line here. The line that I just drew is blue. I want to know what the slope of that line is exactly. Now, first of all, do you know if the slope is going to be positive or negative? Positive because it's going uphill, so the slope is going to be positive. So how do I find the slope of the line? Pick a point on the line, on that line, and get off the line and get back on the line. Alrighty, so here's what I'm going to pick, and I'm usually going to pick an easy set of numbers that actually hit on a direct line. So for example, let's say if I pick this point because it's on the line, and I want to make my way to this point. My goal is to get to that point. I got to go from the first blue point that I just dotted to the last blue point that I dotted. Now, in order to do it, you have to get off the line and get back on the line. So what I'm going to do, remember we said rise over run? We're going to use the key items called rise over run to actually do this. So here, I want to rise how many? 1, 2, and 3. So I rose up 3. How many did I go to the 1 to the right? So then I go 1 to the right, so I ran 1. You okay with that? We went up 3, we counted up 3 and over 1. So the slope, which is m, remember the slope equals m, so the slope for this is just 3. Because 3 divided by 1 is 3, correct? Okay, so you just figured out the slope of that line. Now, did I have to pick those 2 points that I dotted? No, I could have picked any 2 points as long as it lands exactly on a good number that you can tell what the number is. So here's what I mean when I say that. Could I have picked, for example, let me erase the points that I picked. Could I actually have picked this point right here? You don't know what number that is. I don't know what number that is. It didn't land directly on one of the actual intersecting lines. It has to land on one of the intersecting lines. So you can tell exactly what that number is. So you won't have to say, well, it's 1.5679. I don't know what it is. Pick a point that's at the intersecting lines that you see from the graph. So what other points could I have picked? Could I pick this point and that point? Yeah. So if I pick that point, could I pick this point up here? Sure. So let's pick another point and see what happens. Now I'm going to go a different direction. I'm going to start at the top point and make my way down. Start at the point up here at the top. I'm still going to do rise over run. So here, start at this point. I need to get back to the point down here at the bottom. So I'm going to either rise or run, whichever one you do first. Does it matter whether I rise or run, which one you do first? No, it does not matter as long as you get back from this point to that point. So what I'm going to do first is I'm going to go left 1. Left 1, so over 1 to the left. Left is positive or negative? Okay, was that a run? Anytime you go this way, it's a run because you run straight back and forth, right? You don't run up and down, right? All right, so here we're going to run -1. So we went left 1, so my run is -1. And then I'm going to rise always refers to up and down. It says rise, but it refers to up and down. So if you're writing notes, rise refers to up and down, run refers to left and right. Right? You okay? All right, so I've already ran to the left 1, which was -1. Now I'm going to come down 1, 2, 3. So since I went down 3, what should I put here? For the rise, I'm putting a -3. Now if I do the math, negative divided by negative is a positive, so it's still going to end up being a +3. So it doesn't matter if you start at the top point and come down or start at the bottom point and come up. You still should get the same answer. Question? Alrighty, you're good? Alrighty, so here is the next slide. Sometimes you're going to see it give you some points and they want you to actually do the slope formula. Have you guys seen the slope formula? Don't worry about where you see the triangle and the y, because you would get to that if you were going to do some calculus. But since are y'all going to do some calculus? Maybe. Not anytime soon. So you don't need the delta y and the delta x. It just says the difference between the y's and the difference between the x's. That's what the delta, the little triangle means. All right, so you won't use that. So here, in this particular case, they're going to give you 2 points. You're going to label them and just plug the numbers in and do the math to calculate the slope. So the previous slide, we just did the slope doing our own up and down and right and left on the graph ourselves. That's a manual figuring the slope. Now you can calculate the slope actually using m equals, so in the place of this, you see slope m equals y2 minus y1 over or divided by x2 minus x1. We're going to just give you numbers and you plug them in. And you just do the math. So, with that said, here is your next slide. Alrighty. They gave us some points on this next slide. We have some points. Can we use our formula? Yes, you can use this formula. Will you need this formula on a test? Yes, you will. Okay, so let me erase it since it's already written here on the screen. Alrighty, so does it matter which 2 sets of points I pick? No. Any 2 points on that line that you see, here's the line that we're talking about. We already know the slope of this line is going to be positive, right? Okay, so all I need to do is figure out what the exact number for the slope is going to be. So, pick any of the 4 points, pick 2 of any of the 4 points so you can figure out what the slope is. Well, they picked 2 for us. They picked the 2, 3 and the 3, 6. Now, when you label them, it's your choice how you choose to label them. I'm going to label them like this. This is x1, y1, the first point. x2, y2, it's the second point. And literally, I'm just going to plug those numbers into that equation. So, the 6 is your y2. This 3 in the first ordered pair is your y1. So, I put 6 minus 3, which is 3. Go to your x values. x2 is 3 and x1 is 2. Subtract me, you get 1. Notice we still got the same slope. Okay, well let's pick 2 other numbers. Instead of 2, 3 and 3, 6, let's pick 2, 3 or pick the other 2 numbers. Let's pick the other 2 numbers. 1, 0 and 0, -3. Let's do the same formula for those 2 numbers. Again, we picked 1, 0 and 0, -3. I'm going to fill it into the same formula. You got to label them. So this is my x1, y1, x2, y2. Excuse me, x2, y2. All right, so I'm just going to plug them into the formula. Alrighty, here's my formula. What should I put for y2? -3, so this is going to become a -3 here. Let's erase this and write that properly. -3 minus what? Minus 0. So that's going to be a 0. On the bottom, what should I put? x2, 0. Minus what's minus 1. Alrighty, so now if we keep doing, -3 minus 0 is -3, and 0 minus 1 is, and then -3 divided by -1 is a +3. We still got the same answers. So it doesn't matter which 2 points you pick from the line, you should get the same answer. All right, questions? Here's your turn. Go. Let me write the formula back on the board. You have 2 points, -7, 3 and 5, -1. I need you to find the slope for those 2 points. Let me put the equation back up here on the board. M equals y sub 2 minus y sub 1 over x sub 2 minus 3. That's what you got?
Yeah.
Okay. I'm just waiting to see, make sure you have time to plug it into the calculator. This one is important because you got to make sure you actually do those negatives right. Again, here's the formula. I'm making sure you do the negatives right here when you actually, let me scoot this over here. So when you do this, let me label. Let's see if I just wrote it right. Negative 1 minus 3, okay? And then I've got when you put yours in, did you write yours like this? Notice you had two negatives right here. Did you see those two negative signs? And a negative turns into a? Okay, so that's going to be positive. So this ends up being a plus sign. Let's write this underneath here. 1 minus 3 over negative 5 plus 7. So that's going to be what on top?
It's a positive 5.
That's a positive 5? Whatever. Oh, negative 5. Thank you.
On top of the
Negative? Okay, negative 4 over 12. Ah, can we leave our answer like that? Negative 4 over 12. You got to simplify it. If you're on a test and you don't simplify a fraction, if you're in my math lab and you don't simplify it, it's going to mark it wrong. On a test, if you didn't simplify it, you'll get partial credit because you didn't finish the problem. So, for example, if you got all the way down and left there, you might miss 1 point, you might miss 2 points if you didn't simplify the fraction. So here you go. So what does this simplify to? How did you get those numbers? 1/3. Negative 1/3. How did you get it? You found a what number? What's that number called that you found that divided into both of these numbers? Greatest common factor. So you found the greatest common factor was 4, and you divided both of these by 4. So it's called the GCF, which is the greatest common factor, which is 4. So when the greatest common factor is, what's the largest number you can find that goes into both 4 and 12? And it just happens to be 4. If you had said 2, 2 would have divided into both 4 and 12, but is it the greatest one? No. Okay. All right. So then once we do that, we end up with, you said negative 1 over 3. Done. Questions? Next slide explains it just like what we did. So is it a downhill slope? Yes. It's negative, so it's going to go downhill. Questions? All right. We talked about the y-intercept for a second. It's the point where the line crosses or intersects with the y-axis. Whenever you draw a line, any type of linear function is a line, it's going to have where does it cross or touch the y-axis. There will always be a point. Yes, it's represented by the letter B, and the point will always be, and let's make sure you're okay with this point. If I have a line right here, and this is 1, 2, and 3, 1, 2, and 3. And I say this blue line crosses at y, where see y is at 3. It crosses at y equals 3. That's my y-intercept. You okay with that?
Yes.
Can you name that point for me?
0, 3.
There we go. So every time, if it asks you for the ordered pair, it's always going to be a 0 first. Every y-intercept will always have a 0 first if they ask you for it in ordered pair form. So you say, they say, what's the y-intercept? And they say, let me have it as a ordered pair. You got to write it like this. If they don't say ordered pair, write it like that. You're just going to put 3. Y equals 3. That's it. So it just depends on how they ask you for your answer. So make sure you answer it in whatever form they ask you to answer it as. There we go. How do I find my x and y intercepts? If they are not given to me, how do I find them? This screen just tells you what to do. word for word. And we can do this word for word, so I'm going to do it on the next screen so you can see the example that we're going to follow. But literally, to find the x and y intercepts, by calculating them, you follow these steps exactly to the T. So for the find the y-intercept, if they didn't give it to you, set x equal to 0. That means plug in a 0 for x and solve and get y by itself. And the second one, if you want to find the x-intercept, set y equal to 0. That means plug in a 0 for y and solve and get x by itself. Whenever you're finding a y-intercept and they ask you for it in an ordered pair, it's going to be 0, comma, and whatever that number is. Just like we just said, if it doesn't say an ordered pair, then the answer is just going to be whatever the number is. The solution is just whatever that number is. If you're finding the x-intercept, your ordered pair is always going to be the number first, then the 0. Did you understand what we just said? For y-intercept is going to be 0, comma, and whatever the number, like we did with the last one, is 0, comma 3. If it's an x-intercept, it's going to be the number, and the 0 is going to be last. So that's what we got. So let's do the next one, which you'll see on the next slide. Find the x and y intercepts for the equation 4x minus 8y equals 16. Find the x and y intercepts of the graph 4x minus 8y equals 16 algebraically. When it says algebraically, they want you to work it out by hand. Okay? Is there a way to do this in Desmos? Sure, you can type this in Desmos just like it is. And it'll tell you where it crosses the x-axis and where it crosses the y-axis. So if we go there now, let me show you actually go there now so you can see for sure 4x minus 8y. Delete the equation that's there. What was that? 4x minus 8y equals, not equals, equals 16. There's your line. Can you see it? Now, can you see the points that cross the x-axis? Yes. Or the point that crosses the x-axis? If I click on it, there it is. Ah, that's my x-intercept, 4, comma 0. What's my y-intercept? There it is. Now, for test purposes, just so you'll know, I will not let you use Desmos for this because it's too easy. So now I'm going to ask you to do this algebraically. So let's go back and do the algebra form of this same equation. We'll go back and just do the algebra for it. So I'm going to go back to the PowerPoint screen so we can see what we're working with. All right, here we go. Step 1, again, I'm finding the x-intercept first. Find the x-intercept. Over here, we're going to find the y-intercept. All right, so step 1 for the x-intercept. Plug in a 0 for y. It says set y equal to 0. Plug in a 0 for y. Alrighty, so here's my equation, 4x minus 8y equals 16. I'm going to plug in a 0 for y. So that's going to be 4x minus 8 times 0. What's 8 times 0? 0. So now the 8 times 0 crosses out since that's equal to 0. So that's gone. So now I'm left with, on the left side of the equal sign, I've got 4x minus 0, which is just 4x. So 4x is on the left side equals 16. This is solving to get x by itself. How do I get that x by itself when I have 4x equals 16? Divide both sides by 4. Whatever that coefficient is, this number that sits in front of the x is called the coefficient. Whatever the coefficient is, you divide both sides by it. So divide both sides by 4. So x equals 16 divided by 4 is how much? 4. So what's your x-intercept? 4. But if I say what's the ordered pair for that x-intercept, what you gonna tell me? 4, comma 0. Either one of these answers is right. Just know how my math lab wants you to write it. It might say just tell me 4, and it might say give me the ordered pair. All right, now let's find the y-intercept. For the y-intercept, plug in 0 for x. All right, so I've got 4x minus 8y equals 16. Plug in a 0 for x. So I got 4 times 0 minus 8y equals 16. 4 times 0 is what? All right, so I've got 0 minus 8y equals 16. So 0 minus 8y is negative 8y equals 16. I want to get y by itself. What should I divide both sides by? Negative 8, okay. So what's 16 divided by negative 8? All right, so where does this graph of that line cross the y-axis? At negative 2. Okay, at negative 2. What's the ordered pair for that y-intercept? 0, comma, negative 2. Questions? That's the work that I would expect to see on your paper for test purposes. Now, can you skip steps? Sure. Like, you don't need this. You know 4 times 0 is 0. You didn't need this step at all. I always put extra steps because when I was taking math and the teacher skipped a step and I'm still trying to figure out how did you go from this step to that step. So you usually give extra steps that are not necessary, but it lends itself to making sure you understand how I got from each point to each point. So for test purposes, if you skip this step, I'm cool with it. If you got down here and you put this and jumped all the way down and said, well, I already know it's going to be a negative 2. I'm not even going to show her I divided both sides by negative 8. Fine, I don't have a problem with it as long as you know your answer's right. Now, if your answer's wrong and you didn't show me your steps, then I can't give you the most credit for the problem. So I would say show me whatever steps you need to show me to make sure that you got it right. All righty? That's what I would be required, that you will be required to do on any test for that type of a problem. So here is the slide that actually shows you how they worked it out. Let's erase what I wrote so that you can see the actual work they did. Now, can you see that they skipped some steps? Yes, they did. I gave you the extra steps so that you have that. But they did the exact same thing that I did. They didn't say, hey, divide both sides by 4. They just assumed that you already knew how to do that. All right, questions? All right, here is last couple of slides. It's just saying basically making sure you understand what the y equals mx plus b means. And you can create points just by plugging in numbers. So if you decided, hey, I'm not going to type whatever this equation is in decimals. I just want to figure out what some of the points are for that line. You can plug in numbers for x if they gave you m and b. So if they said y equals 3x plus 5, which we used at the beginning of the class, can I find points for this line? Sure. Plug in a 0, I'm going to get a number. Plug in a 1, I'm going to get a number. Plug in a 2, I'm going to get another number. So you can take this equation and create your own set of points for that line if you like, and if it's you're asked to do that. Just making sure you can create the line by just connecting the points. So if I plug in a 1 or 0 here, if I plug in a 0, I'm going to get what? 5. If I plug in a 1, I'm going to get, if I plug in a 2, so you see, how many points does it take to make a straight line?
2.
Just 2. All you need is 2 to connect the dots and make a straight line. You only need 2. So you can see you can create points that will actually make a straight line. Alrighty, next slide here. I want you to tell me, based upon what you see, they call the constant, which is the same thing as the y-intercept. It's the number that does not have a variable attached to it. The constant is a number that does not have a variable attached to it or sitting right next to it. So which is the same thing as the y-intercept here. The coefficient is the number that sits to the left of the x value when it's written in this format. What format is this written in again? What format is this equation written in? Slope-intercept. All right, the previous equation that we had on the board was 4x minus 8y equals 16. Is that written in the right form, in the slope-intercept form? Look at this equation and look at this. Is this one written with y equals mx plus b? No, it's not. This is called general or standard form. When the x and the y are on the same side of the equal sign, it's called general or standard form. So, can you know what the slope of this line is? Just by looking at it? Just by looking at it, can you know what the slope is? Say no. Why? Because it's got to be written in this format. Okay? So if it's written in general form, you can't tell me the slope. Now, the temptation is, and it's on every test, you see 4 in front of the x, you be like, the slope is 4. And it's not 4 unless you write it in this format. So you would have to go rewrite this equation getting y by itself in order to tell me what the slope of this equation is. Or you can just plot some points and do the slope formula. So we'll get to another one of these where you got to convert it. All right, so let's get back to this for a second. On the screen you have three equations. Are they written in y equals mx plus b form? Yes, they are. Here's my y, here's my m, here's my x plus b. So in this case, what's the slope for the first equation? What's the y-intercept? 1, so that means that's where it intercepts, touches, or crosses the y-axis at 1. All right. Tell me what the slope is for bullet number 2. -1. Whenever there's a negative in front of a variable and there's no number, you do know there's an imaginary 1 there, right? Okay, so this is, slope is -1. What's the y-intercept? Okay. First equation, slope uphill or downhill? Uphill. Second equation, slope uphill or downhill? Downhill. Last one. We have a slope that's interestingly different than what we've been seeing. Is it okay to have a slope as a fraction? Sure it is. So in this case, m is 3/2 or 3/2, however you want to say it. The slope is 3/2. Is it uphill or downhill? Uphill. Because it's still positive, right? Doesn't matter that it's a fraction. It's still uphill. Could this number be, instead of me writing 3/2, could I write 1.5? Let me write this so you can read it. Could I write 1.5x minus 2? Does the slope have to be a fraction or a whole number? No, it could be a decimal, a fraction, an integer. It could be any of those numbers. So I could write it like this, or I could write it like that. The slope is still positive 1.5. What's the y-intercept for that one? -2. So it's going to touch or cross the y-axis at -2. Questions? Alrighty, so this next slide shows you the answers of what we just figured out. Alrighty, next slide. Alright, back to real life. Last question before we stop. Alright, everything in this class relates back to real life, right? We've been talking about equations that's written in y equals mx plus b form, right? So here we go. Let's see what we did. What's the first thing we're supposed to do when we get a word problem? Read the problem. All right, let's read it. The amount of money, y, the amount of money is called y, that's remaining to be paid on a loan of your $60,000 Escalade with $16,500 in interest is given by the y equals 76,500 minus 1275 x, where x is the number of monthly payments you have made. All right, so question, do you understand what the topic is? Yes? Any of us who've had car notes or truck notes or whatever, house notes, you actually understand what we're talking about, right? All right, so what I want to ask you is, here is an equation that they gave you. So they gave us some information. They said that we paid a loan of, how much was the car originally when you went and got it? Okay, where did this number come from, the 16,500? You got to pay interest. People ain't going to let you borrow money and not charge you for it, right? So the truck was 60,000. Now add another 16,500 to it. So in the end, how much money are you really paying for that truck? You end up paying 76,500 for the vehicle. Why do you think it's a minus 1275 right there? Guess what you think? Why? What is that? That's the monthly payment that you're paying on that vehicle. Okay, should there be a subtraction sign? Think about it for a second. You're making what? You're making payments. Don't you want the money to go down as you pay it off? Don't you want that number to go down? Okay, so you are going to be subtracting. Now here's my question. Is this statement or this equation written in mx plus b form? Say maybe. It's out of order. So here's my question. Can I write mx plus b like this? Does these two things mean the same thing? Say yes. Right? What I'm saying to you is, can I write it with the b first and the mx second? Yeah, sure I can. So can it be out of order? Yes. Yes, it can. So why do you think they wrote it out of order though? Why didn't they write it like this? Why didn't they write it as negative 1275x plus 76,000, 500? They wanted you to see that you're going to subtract your monthly payment every single time. So they wrote it like this intentionally to say, I started out with $76,500 worth of debt to whatever bank company or bank or finance company, and you're subtracting 1275 times, what's X representing this formula? Look at what it says. What does it say X is? The monthly payments what? Read the rest of it. That you already made. You don't want it just a monthly payment. It's the number of monthly payments that you already made. So if you made 5, then you got to multiply 5 times that and subtract it from what the original payment, that the original cost of the vehicle is. So this is always X is the number of monthly payments that you already paid. We got it? All right. So is this equation written in y equals mx plus b form? Yes. Just the mx and the b got switched around. Is it okay to do that? Yes. All righty. So what's the slope? You can look at it this way or you can look at it that way. What's the slope? Is it positive or negative? Bless you. Is it positive or negative? Negative. Why? Okay, your payments, you do want your payments to go down. You do want what you owe on the vehicle to go down, don't you? So when you graph this, what should this graph look like? Alrighty, where did you start? Here are monthly payments right here. These are all the monthly payments you've been, this is, X is equal to this. These are the months. Okay, these are your months. And how much money you owe. Because again, Y is the amount of money remaining to be paid on the loan. Remember, the Y over here is how much you still owe on the vehicle. Again, this is the amount you still owe. How you going to figure out how much you still owe? You got to subtract the payments you already made. Amount you still owe is your Y value. So here is, well, how much did you owe when you drove it off the lot? Okay, so 76,500 go up here. This is how much money you owe on day 0. You just bought it. So here's 0. You nicely drove it off the lot. Now it ain't worth 76,000 once you drive it off the lot anymore. But however, you still got to pay 76,500. All right. So at 0, you owe this original amount. What should happen as I go out and start making payments? It should come down. So as you make payments, should it end up at the x-axis? Yes. At some point when you've done what with it? Once you have paid it all, this should be in whatever month that is. Now you can get it up to what? Is it 72 months, 84 months? 72. They'll let you do what? Almost 7 years now on a brand new vehicle. Is it 7 years? Alrighty, so that's what that graph should look like, and you better be going down. You don't want it to be going up because you want the payments, you're making payments, so it's going down. So here's the question that you're being asked. What's the slope? Negative 1275 is the slope. Questions? We see the graph. Where does it intercept the y-axis at? 76,500. Up here. And where does it intercept the y-axis at? It's going to be at 0. How many months? It depends on how many months it takes us to pay it off. So we would have to do some calculations to figure out how many months it would take. We just wanted to see what the slope was and what the y-intercept is, and make sure we understood what those values mean. Can you see how this is a linear function associated with anything you make a monthly payment on that you got to pay off? You can write this equation for it. Okay, all righty. That should be okay. We're at 10:51, which finalizes this particular section. So we are good to go. We are good.